synopsis that we sent out, I mentioned that Alexandria Ocasio-Cortez's quote that, or that the New Green Deal being that they want to upgrade all the buildings in the United States to be more green and all new buildings to be more green. So the question really is, well, how do we do that? And I feel like an important leverage point is through automation. And it's something that's kind of unavoidable, going into the future. So that's really the problem that I'm trying to tackle here. So specifically, I'm using fractal dimension as an objective function with a genetic algorithm. So I'll explain how that works. But in architecture, fractals have been kind of part of the art of architecture since time immemorial. And until the 80s, Benoit Mandelbrot, did we really have the word fractal and have a mathematical, quantitative approach to studying fractals. Whereas throughout history, we can see architects using fractals in their geometries. And there's also a strong connection to nature and to so there's a lot of algorithmic design kind of being investigated and explored in architecture, and some of this stuff is really, really fascinating to me. And there's kind of like the emergent paradigm, which is that the whole is greater than the sum of the parts, it's superadditivity. And then there's the fractal or holographic idea that the part contains the whole, which is more like this idea of DNA. Within the part is the seed for growth that is basically like an algorithm. Algorithmic architecture is nothing new. We see that there's been a lot of exploration. Here's Antonio Gaudi's upside-down chain building, where he's studying forms that are in tension with catenary curves. And he flips this upside down and it becomes a completely compressive form that he can use masonry elements to build. And this was just a building going up in Seattle soon where they're 3D printing elements of the facade. Are people here familiar with Game of Life and CAs? How about Golly? Has anyone played with Golly? Golly is a tool. You can download it as open source, where you can basically program with CAs. And Wolfram has shown us that Rule 110 for an elementary CA is capable of universal computing. So anything you can do on a computer, you can do with an elementary CA like this. So the question I guess I'm asking you hypothetically is nature using a CA in its algorithm for how it defines growth patterns? I explored that earlier with Game of Life kind of strategies where each successive iteration was laid on top of the iteration before it, so it creates this three-dimensional object. So it's a two-dimensional plane of cells, but then it's kind of additive, so you create these objects. And they have obvious fractal qualities. You can see this kind of bifurcating branching structure starts to happen. And they're all based on these very simple rules. So at what point does that become architecture and enclosure? Or, this is my CA taxis. Some of them are, they're all interesting, but some of them are mind-boggling. That they have these, this one in particular, it has a strong axis, and they don't cross over. So it's like kind of geometry for free. You have a simple rule set, and you can create these really complex objects without having to actually define them, like with the blueprint. Instead of having this complex representation system, you can just represent this object with a simple line of code, and then you can create a rich kind of tapestry of form. So now I'm moving from that into this model that I'll present today, which is this guy, which is using this fractal dimension, and a method I'm calling the Wollendorf method, which he was my late professor. This is like a kind of a composition 101 problem or exercise where you have a sheet of paper and then you're asked to put down a number of lines that are orthogonal, and then this is used to communicate or to teach basic principles of composition, like focal point and secondary focal point, and rectangular motion, terminus, symmetry, asymmetry. All the gamut of compositional elements are embedded in this little exercise, and then you choose some of these to be masses, and the masses are extruded into the third dimension. So when I interpreted this in code, I basically am using just random configurations to start with, but then we're selecting for higher fractal dimension or a target fractal dimension, which creates the multi-level complexity and potentially more interesting compositions. So then I have a team of architects that are I'm sending these designs to, and then they're reacting to it. I've taken this tool now and designed it as a plugin for SketchUp, which anyone can use. So it's you can create an object with certain parametric inputs relative to a building problem, and then those parameters can be defined. As the architect kind of under the hood can reprogram the tool to have additional parameters that could be useful for that particular design problem. So instead of just using CAD or BIM out of the box, here now we're able to redefine the CAD system so it can compensate for the unique qualities of that particular design problem that we want to solve. The project I have is one that I competed for professionally with a team of architects, and we didn't win. But I learned a lot about this project, so I'm using it as my kind of case study. And it's a mixed-use project in downtown Ithaca for affordable housing and ground-level retail, and a new bus station, which is desperately needed. So I've interpreted. There's some models on the table you can pass around that are 3D prints of this. But I'm looking at the design from 3 levels of scale. So the top is like the level of the masonry unit, the block. And then this is kind of the architectonic, like human scale, where you could actually occupy this or use it. It's useful, it has function, like a staircase or fenestration elements, or something like this. This is like an outdoor pavilion for music or outdoor events. And then you have the kind of macro scale, which is the scale of the city block or the partie. It's hard to see, but you may be able to see it in the model. But this block, the composition of this block is reflected in the facade of the building. So this becomes kind of the partie for the building overall. So the design of the block, these slides are at the micro level. So we look at kind of integrating. The way that the plugin works is that the computer will come up with these different designs with a fractal dimension, and then you can choose some of them to be seeds in the genetic algorithm, and then it will spit out the next generation of designs, and you can. So there's a level there where the human is kind of the matchmaker, where you're choosing which components to use to procreate for the next generation. Mm-hmm. So that's kind of a level of design happening, mm-hmm. which is kind of interesting. So, recursive process that's happening at a small scale. And then you can kind of extrapolate that. So the design process itself could be a fractal process where you have this recursion happening at a small scale, and then also happening at larger and larger scales. here the block is being used to create panels. And now I'm taking this meso-level look at breaking up the facade to have kind of a mid-level of detail. It's a tripartite approach. So the massing study for the macro level, which is basically the block with now I'm pushing and pulling different elements. But I thought about this problem, and I talked to the stakeholders on for this project for 4 months before I designed anything. So the owner of this building was the person that was backing our proposal, and they really wanted to preserve their views, and all the other proposals the city had were maximizing basically the boundaries and the height limitations of the site. So they were blocking the views for this building. So I pulled these masses apart and put the masses on either side so they could retain their views, and then kept the center mass to 5 stories. So that could also be shaded with deciduous trees for solar reasons. So after, let's say a schematic phase is finished, then I'm doing this kind of post-analysis of the different elements at the different micro, meso, macro levels. And what I found here was that typically the fractal dimension increases as you zoom out. So the macro building has a higher 1.589 than the meso level, which is 1.26. And I think this is true often. I studied the fractal cartography of Portland, and I found that if you zoom in, the fractal dimension tends to get smaller, and you zoom out, it tends to get larger, which kind of intuitively makes sense that things are more complicated as you look at the larger scale. But the idea here is that it doesn't have to be that way, that you could have complexity happening at every level, and that would give you a sense of identity for this, the building at large, that you would see it has this consistent level of detail, instead of, say, international style or something where you get to a certain scale and suddenly it becomes blank. There's nothing left. It's just like one solid object without that kind of cascading level of detail like we see in Frank Lloyd Wright's buildings, and Antonio Gaudi's buildings. And in nature, where every scale you choose to look at, there's kind of interesting things happening. So this was looking at the building behind my building, and then its dimension is 1.516. So there's a contextual link that you could say, we could look at the architectural context of the site as well as the landscape of the site, and make a relationship between the multi-level complexity of the building with the multi-level complexity of the surroundings. And that opens up a door to other research that's been going on with looking at the fractal dimension of landscapes and how it could affect human health, and kind of evidence-based design. The fractal dimension of the savanna, and saying that there's something about, there's some sweet spot in there, 1.7-ish, where you have kind of enclosure in the foreground, like a low-hanging tree or a cave, and then you have this kind of savanna, and then a water element in the distance. So that would be a good hunting ground, as well as good potential protection from predators. So I think that's it.